All right. So, hello everyone. Today we are going to learn about another form of your material failure, that is about your fatigue. Okay. We know we have learned about your fracture. This is one of the concepts in which we separate the material. That is nothing but the separation or the breaking of the material into two or more parts under the application of the law. Right. Similarly, inside your fatigue, what happens that instead of a normal tensile load that is applied, a cyclic loading is being done. Okay, and the material fails because of the cyclic loading. Okay, similarly, there is another concept that is also related to the failure of the material, that is related to your creep, which is nothing but the deformation of the material or the breaking of the material that takes place at the higher temperature with a constant loading condition with respect to your time. Okay, so we'll be discussing about your fatigue failure too. So let me just share the screen. Okay. So as I told you that under your fatigue failure, the fatigue failure is basically caused because of your cyclic loading. Fatigue failure occurs because of the cyclic loading. Okay. So instead of applying one normal load, in general cases, we apply a cyclic load, that is, say, one time it is a tensile condition, then there is a compressive condition, and so on. Okay, so such a kind of a condition is basically responsible for your fatigue failure. Okay. All right. So as we are discussing about the cyclic loading, it is very important for us to understand what are the different types of loading, right? So our very first topic related to your fatigue failure will be related to your loading type. Okay. So what are your loading types? The very first section is related to the types of loading. Okay. So your very first part is related to your reverse loading. What do you mean by your reverse loading? Okay. Now, please understand, if I draw my stress versus the number of cycles for my reverse loading condition, that term itself will be very clear. Okay. So if I draw my stress versus number of cycles, this is my cycle. The number of cycles is represented on the x-axis, and the stress is represented on the y-axis. Okay. So this loading is basically known as the reverse load. Okay. So this is my sigma max value. This position represents the sigma minimum value. Okay. Such a kind of a load is basically known as the reverse load. Okay. Now it is actually very clear from the curve itself, from the plot that we have drawn for your reverse loading, that the maximum value or the maximum stress that is applied over my material, it is a tensile stress, right? This is my zero. So this is definitely a positive stress condition, right? Whereas sigma minimum is a negative stress condition. So sigma max is greater than zero, or I can say that when sigma max is nothing but a tensile stress. Okay. Whereas sigma minimum is less than zero, which is nothing but a compressive stress. Okay. So such a kind of a loading is basically known as a reverse loading. Basically, if I have a material, okay, once the tensile stresses are applied over the material, and another time, sorry, the compressive stresses are applied over the same material, such a kind of a loading is known as a reverse loading. Okay. All right. Now moving on to our next part. Your next type of loading is basically known as a repeated loading. Okay. Now please understand. If I draw my stress versus number of cycles, it will be very much simple to understand, right? So let me just draw it. This is my stress, y-axis, and this is my number of cycles. Okay. So in your repeated loading, all the conditions, it is also known as your all tension condition. Okay. Your repeated loading is also known as your all tension loading or all tension condition. Okay. And under all tension loading, only the tensile stress is relevant, right? Only what changes is nothing but your sigma maximum and sigma minimum value. Over here, this is my sigma maximum. And this is my sigma minimum. Now please understand, both of them are in the tensile region. The sigma maximum and sigma minimum both lie under your tensile region. Okay, so such a kind of a loading is basically known as your repeated loading. Okay, now moving on to our third part, that is about your irregular loading. Okay, now in your irregular loading, this is a different kind of loading. Say, if I draw my stress versus number of cycles curve, so in my irregular loading, there is no particular condition that what is my sigma maximum and what is my sigma minimum. Moreover, the load that is applied is not a fluid load. Okay, say if I draw the curve, it is somewhat like this. Okay. What does this represent? It basically represents that amount of stress that is applied over my material with respect to my cycle is varying randomly. Okay, it is not like a particular manner in which means a particular amount of load is applied over the material, but a random kind of a load. Okay, now you can understand it with the help of an example. For example, the wings of an airplane, wings of the airplane. Okay, they experience your irregular load. Okay. How does they experience this irregular loading is what we need to understand. Okay, when the airplane is floating, whenever it is flying. Okay, so what happens that say it is in the hilly area where the moisture content is high, right? So if my moisture content is higher, then definitely there will be more atoms which will be colliding with the wings of the airplane. Okay, and different kinds of your loading condition will be experienced. Okay, such a kind of a loading condition is known as your irregular. Okay, so these are the three common types of loading which are responsible for your fatigue state. Okay, all right. Now let us move on and learn about some terminologies that are commonly used in the fatigue test. Okay, all right. So learning about these terminologies. Your very first terminology is about your mean stress. What is mean by your mean stress or your amplitude? Mean stress. Okay. What is meant by your mean stress? That is represented by your sigma. Okay. This is nothing. This is nothing. But if I draw a repeated cycle, let me draw just a repeated cycle, and then it will be very much easier. Sorry, reverse cycle, right? And then it will be very much easier. So this is my sigma max, and this is my sigma minimum value, right? This is my number of cycles, and this represents my sigma. Okay, so what is your mean stress? Your mean stress is nothing but the maximum sigma plus your minimum sigma. Fine. That is the mean of the two stress. Okay, all right. So similarly, next comes your stress amplitude. Stress amplitude, which is nothing but represented as sigma A. Okay. Now this is stress amplitude, the sigma A, is nothing but this value. This is my amplitude. Similarly, this is my amplitude. Okay. So I can directly calculate what is my stress amplitude, right? It is nothing but sigma maximum minus sigma minimum. The difference between the two. This is my sigma maximum and this is my sigma minimum, right? The difference between the two. If I divide it by half, that is, if I halve the value, it will basically give me my stress amplitude, right? So this is my stress amplitude. Sigma maximum minus sigma minimum. Right? Okay. The third terminology that is also used is nothing but your stress range. What is your stress range? Okay. So your stress range is given by sigma r. Okay, and this stress range is nothing but sigma maximum minus sigma. Okay, which, or I can say that this is nothing but 2 times of your stress amplitude. Okay. All right. Now the fourth term is about your stress ratio. The stress ratio is basically given as, you can directly note this term. It is represented by your capital R, and your capital R is nothing but sigma minimum upon sigma maximum. The minimum stress upon the maximum. Okay. All right. Now the final terminology that is used is about your amplitude ratio. Now this amplitude ratio is represented by a capital letter A. Okay, and as per my amplitude ratio, this is nothing but sigma maximum minus sigma minimum upon sigma maximum plus sigma. So the ratio between your sigma max minus sigma minimum divided by your sigma max plus sigma minimum will give me my amplitude. Okay. All right. I hope it is clear to all of you what is that. So what are the terminologies which are used inside the fracture of inside the fatigue of the material. Okay. All right. Now moving on to our third part that is basically related to your essential. We'll see what is your essential. How are they generated for different materials and what is your endurance limit and the number of cycles we'll learn about. Okay. All right. So your SN curve is nothing but a plot between the stress amplitude versus the number of cycles. Okay. It is a plot between stress amplitude versus number of cycles. Okay. Now, this SN curve basically represents that what amount of means how many cycles a material can withstand at a particular stress value without failure. Okay, mainly. Your SN curve is somewhat like this. This is my x-axis, which represents the number of cycles n, and this is my stress, right? In terms of my stress amplitude. Okay, so most of my material follows this curve. Let me name this curve number one. Similarly, there are some materials which follow this kind of a curve also. And this limit is known as the endurance limit. Now, please understand what is meant by your SN curve and how are these curves plotted. Okay, so basically, this first curve is common for most of the metals. Okay, say for example, I am taking for aluminum. Okay, now what does this curve represent? Is that at a particular stress value, say I am taking this stress value, how many cycles can a material can withstand without the failure? Okay, so if I am taking this stress value, okay, so I will draw a straight line, right? A horizontal straight line which will intersect with this curve. Okay, so the position at which it intersects with the curve will basically give me the number of cycles which the material can withstand or the aluminum specimen can withstand without failure. Okay, so let me take this as my n number. Okay. All right. So this endurance limit. Okay. Now coming on to your second curve. This curve is mainly common for your titanium or mild steel. Okay. Now, in case of your steel or your titanium, what happens that you obtain an endurance limit. Okay. Now, this endurance limit basically provide us about a stress value below which the material can withstand infinite cycles without failure. Okay. For instance, if I take the same amount of stress that is failing my material, the aluminum specimen, add the number of cycles of M1. Okay. Then it will you can easily draw a straight horizontal line, right? Now you can see that this horizontal line that is drawn at a particular stress value, it will never intersect with my curve two. Okay, so if it is not intersecting with my curve two, definitely the material or in this case the titanium specimen or your mild steel specimen, they can withstand the infinite number of cycles without failure at that particular stress value. Okay, so it can withstand up to infinite cycles without failure at that particular step. Okay. Now this curve one that is represented for my general metal. Okay. This curve is basically drawn with the help of my Baskin's equation. Okay. So it is important for us to understand what is your Baskin's equation and based upon that, how this curve has been done. Okay. So as per my Baskin's equation, for general metal, with the help of my Baskin's equation, we draw the curve for curve. So it is basically represented as n into sigma a raised to the power p is small. Where your n is nothing but the number of cycles. Your sigma a is nothing but the stress amplitude P is nothing but your material constant, and C is definitely a constant quantity. Okay. So this is how you represent your SN curve. Okay. All right. So we have learned about your endurance limit. We have seen what is how the SN curve will look like for different conditions. That is for your general metals like aluminum, copper, etc. etc. Okay. And similarly, we have also seen for the SN curve related to your titanium and magnesium. Okay. Now, the stress value is less than your endurance limit, then the material can withstand up to infinite number of cycles. I'm talking about the material that is made up of titanium or magnesium. Okay. All right. So usually the number of cycles where the endurance limit is reached for my mild steel. I'm talking about my mild steel over there. This is nothing but equal to 10 raised to the power 6 cycles or 1 million. So the number of cycles where the endurance limit is reached for my mild steel is nothing but my 10 raised to the power 6 cycles. Okay. All right. Now, what you need to understand that the number of cycles for the fatigue failure is also described into two parts. Okay. Now, these two parts, number of cycles for fatigue failure is also divided into two parts. Okay. Low cycle fatigue and high cycle fatigue. So, if the fatigue failure occurs, when the number of cycles applied over my material is less than 10 raised to the power 5 cycles. That is known as your low cycle fatigue. Whereas if the fatigue failure occurs when the number of cycles is greater than 10 raised to the power 5 cycles, then we call it to be a high cycle. Okay. All right. So I hope all the concepts that I have taken into today's lecture is clear. Okay. And with this, we'll conclude our lecture for today. We'll see more about your fatigue practice in our upcoming. Okay. So thank you.